بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. Technical English and Terminology. Specific heat. Specific heat is defined by the amount of heat needed to rise the temperature of 1 gram of a substance 1 degree Celsius. Water is unusual in that the solid form ice is less dense than the liquid form, which is why ice floats. Water has a high specific heat index. This means that water can absorb a lot of heat before it begins to get hot. This is why water is reliable to industries and in your car's radiator as a coolant. The high specific heat index of water also helps regulate the rate at which air changes temperature, which is why the temperature change between seasons is gradual rather than sudden, especially near the oceans. The oceans and lakes help regulate the temperature range that billions of people experience in their towns and cities. Water surrounded or near cities take longer to heat up and longer to cool down than do land mass. So cities near the oceans will tend to have less change and less extreme temperatures than inland cities. This property of water is one reason why states on the coast and in the center of Algeria states can differ so much in temperature patterns. A southern state such as Gardaya will have colder winters and hotter summers than Jijil state, which is a higher latitude but has a Mediterranean Sea nearby. If you leave a bucket of water outside in the sun in summer, it will certainly get warm, but not enough to boil an egg. But if you walk barefoot on the black asphalt of the street in the southern portion of the great African North Sahara in August, you'll burn your feet. Dropping an egg on a metal of my car hood on an August day will produce a fired egg. Metals have a much lower specific heat capacity than water. Heat capacity indeed. The high heat capacity of water has a great deal to do with regulating extremes in the environments. For instance, the fish in this pond are indeed safe because the heat capacity of the water in the pond means the temperature of the water will stay relatively the same from day to night. They don't have to worry about either turning on the air conditioner or putting on their woolen flip gloves. Water does indeed have a very high heat capacity. One of water's most significant properties is that it takes a lot of heat to make it get hot. Precisely, water has to absorb 4.184 joules of heat, 1 calorie, for the temperature of 1 kilogram of water to increase 1 degree Celsius. For comparison sake, it only takes 385 joules of heat to rise 1 kilogram of copper 1 degree Celsius. The specific heat of water is quite a bit higher than many other common substances. For example, the specific heat of iron is 449 joule by kilogram by degree Celsius. Sand is 830 joule by kilogram by degree Celsius. That's because water comprises of 2 hydrogen atoms and 1 oxygen atom. Is electronegative. In electronegative atom is more likely to draw electrons to itself, because one side of the atom will have a partially positive charge and the other will have a partially negative charge. The opposite charged sides are naturally drawn to one another, forming a weaker hydrogen bond. That's why water is able to flow past itself, but also bond together. It's constantly forming and breaking these bonds. These bonds are also why liquid water has a high specific heat. Any energy put towards heating water is split between breaking the bonds and heating the water. Because of this, it takes more energy to heat water than it does other substances. For example, if you are at the beach on a sunny day, you'll notice that the sand is often quite hot to work but the water always feels cool, even in the showers. That's because sand has a lower specific heat capacity. It takes less energy to rise the temperature by 1 degree. Because water has a high heat capacity, it requires more energy to rise the temperature by 1 degree. The sun puts out a more or less constant rate of energy which heats up sand more quickly and water more slowly.